Hi, STEM explorers. Have you ever seen a secret code? Engineers and inventors use one every day called electrical symbols. Instead of pictures or drawings of batteries, lights, and other electrical parts, we use universal symbols to create what's called a circuit diagram. A circuit diagram shows the specific pieces and the ways they're connected to show how a circuit works. Some are simple, like this flashlight. Some are less simple, like a game controller. And some can get really big and complicated. This is one for a whole car. Circuit diagrams are an important tool to help engineers, manufacturers, and everyone involved to understand the project. The symbols are international, allowing everyone from anywhere to read and understand the diagrams so they can work together. All things electrical, from a simple flashlight to an entire car, start with a circuit diagram. By the end of this video, you'll be able to recognize the common electrical symbols for the spark block components, read and understand circuit diagrams, and analyze a circuit diagram to create a real working circuit. Jumping in to build is fun, but having a plan is an important step to ensure safety for ourselves and our parts when we're working with electricity. Let's take a look at the symbols for some of the basic building blocks. Batteries hold the power for our circuit. Without it, our circuit's not going to do much of anything. The symbol for a single battery cell is a pair of parallel lines, one of them short and one of them long. On the side of each spark block, you're going to see a diagram for the component that's inside. On the battery, there's also a plus and minus to let us know which side is positive and which is negative. This is going to be really important later on. Wires connect the components together. Their symbol's just a plain line. On the spark blocks, those plain lines are straight, but sometimes on circuit diagrams, they can turn and bend in different directions. At the end of the wires is a solid dot. That dot represents a place where two or more components are connected together. Because our blocks are going to connect to each other, the dots will help us to break the diagram down into the individual components and identify the right blocks to build it. In this video, we'll use the red and the black wire. The LEDs are the spark block lights. The symbol's a triangle with a line and then two arrows. That triangle tells us which direction the current flows, and it's going to point towards the negative side of the circuit. It's not going to allow current to flow the other direction. Resistors make sure everything's running with the right amount of power. They protect our components and make sure everything is working properly. The traditional symbol for a resistor is a zigzag line. You might also see the newer international symbol for resistors, which is just a rectangular box. Let's take a look at the LED block. What symbols do you see here? An LED requires a very small range of power in order to work right. Not enough and it won't turn on, too much and it'll burn out. The resistor in the block adjusts the power level so it's the exact right amount for this LED. You can see on the side of the block it has a symbol for a resistor and one for an LED. In this case, it's a 100 ohm resistor built in to make sure that that LED works exactly as it should. Lastly, we've got our switch. It's just like a light switch. The symbol even looks like one. It's a break in a wire with a line sticking up. Now that we know the basic symbols, let's go ahead and use them to build a circuit. We'll start with the simplest circuit we can, just a battery and a load. I'll start by first analyzing the circuit diagram. I see the LED and resistor symbols right here, and a battery symbol right here. I also remember learning that the black dots represent a junction, a place where two or more components connect together. That splits my circuit into two blocks, one with the battery and one with the LED and resistor. Now let's build it. We'll first need the battery block, then the LED block. I'm going to get this clear green one. I'll snap the LED block on top of the battery block, and just like that, our LED will light up. Or maybe it didn't. Anytime an LED is installed in a circuit, we need to make sure it's connected the right direction. Remember from our previous learning that current can only flow one direction through an LED. The symbol has a triangle on it that tells us the direction that current has to flow. Current only flows one direction from the positive side to the negative side. So if the arrow is pointing the wrong way, the current's not going to be able to flow. If you need to, go ahead and flip the block around and connect it back together. Congratulations, you just built your first circuit using a diagram. Now let's create a new circuit that allows us the freedom to move the LED away from the power block. Let's look at this diagram together and see what we can learn from it. Remember, the dots will tell us where component blocks connect together. That splits this circuit into 4 different blocks. We still have the same battery and LED resistor blocks as before, but now there's 2 components with nothing but a straight line. Do you remember what that component is? It's, of course, the wires we learned about. Let's go ahead and grab those components and put the circuit together. We'll start with the battery again and put the LED a little further away this time. Don't forget to make sure the arrow is pointing to the negative side of the battery. Now we'll grab our 2 wires and connect the battery to the LED. We'll use the red one for the positive side and the black one for the negative side. And just like that, we have light. Now let's add another block that'll give us some control over the light. See if you can find the new component in the circuit diagram and install it on your SparkBlocks circuit. If you identified the symbol as a switch, you'd be correct. If you haven't yet, grab the switch block and install it in the circuit. By examining the diagram carefully, we can see that the switch is on the positive side of the circuit, meaning we'll swap it with the red wire block. We can now turn the light on or off using our newly installed switch. Awesome work! Let's go ahead and review what we did. You learned the electrical symbols for the wire, battery, resistor, LED, and switch. You built circuits using these symbols. And you learned how to change and upgrade your circuits just like the pros do. Want to take your learning further? Give this challenge a try.